Hello guys, in this video I am going to explain you what is tuple relation calculus. Okay, so let's start. Okay, so before starting I want to tell you something that there are many students who become serious before 1 month of examination, and there are many students who become serious before 10 or 20 days of their examination, and there are still many students who become serious before 1 or 2 days of the examination. So and then they get to know that their notes are not completed or they are not able to understand some of the topics. So yes, it is a general problem with the students. So it is, I can understand you guys, because this is not a problem. Actually, this is a student nature. So in my tutorial I will provide you good notes and explain you so that you can score good marks in your examinations. So study smartly and don't take any type of tensions for scoring good marks. Yeah, one thing is study smartly for scoring good marks. Okay, so let's begin. Here we are going to learn what is the tuple relation calculus. Yeah, it seems nice by looking this topic, tuple relation calculus, but it is easy. Okay, so let's start. First point is the tuple relation calculus is non-procedural query language. It means it is not generated by means of procedure. Okay, so it is a non-procedural query language. Also, the second point is it describes the desired information without giving a specific procedure for obtaining that information. Okay, so from the first point, it is I hope it is clear that it is not generated by any means of procedure. So it is not basically it will not provide any specific procedure for obtaining the desired information. Okay, so it is expressed as the tuple relation calculus is expressed in this form, where T denotes the tuples and P is formula. Also P is also called as predicate. So what it represent? Basically it is a set of all tuples small t, all tuples t, such that predicate P is true for all t. Okay, I'll repeat. This represent it is a set of all tuples t such that the predicate P is true for t. Okay, the second is, if any representation of this kind, it basically denotes a tuple t on attribute A. Here we are representing the attribute with a capital A, so it denotes the tuple on a attribute capital A. Also we have T belongs to R. Here T is the tuples which are in the relation R. Here small r is relation. So here I am providing all the variables here called here. T is tuples, P is formula, A is attribute here, and R is relation. Okay, so our next point is a tuple relation calculus expression is of the form of this, where P is a formula. Okay, this point is, I hope this point is clear to you. Also the next point is the several tuple variable may appear in the formula. Various tuple variables, there are many tuple variables which may appear in the formula. And it can be denoted by any alphabet letters, small alphabet letters like small a, small s, small t. These all may appear in the formula, which every variable is denoting in a specific type of relation. So and also a tuple variable is said to be free variable. Okay, the tuple variable is said to be free variable unless it is quantified by this symbol. Okay, this symbol or this symbol. If you're writing in this in a copy, then please straight it. Okay, there's a straight line here because I am not symbol to represent this. You can find in the book also. So if you're representing it by using this symbol, so it will also correct. It is also correct. So there are many several tuple variables may appear in the formula. A tuple variable is said to be free variable unless it is quantified by this symbol. Okay. For example, we have this example where t belongs to r. Here t is our free tuple variable because it is not quantified by this symbol. Okay, here the tuple variable is not quantified by this symbol, so it is a free tuple variable, and here r represents the relation. Okay, so let us move with our next example. Here we can see that here s is quantified by this symbol, so here s called as a bound variable. Okay, whereas belongs to small r. Also, tuple relation calculus formula is built up out of atoms. Okay, there are various there are atoms. By using this atom we can build tuple relation calculus formula. Okay, what is atom? An atom has one of the following forms. Atoms has one of the three forms. Here first is s belongs to r, where s is a tuple variable and here r is a relation. It is a normal, or also s is a tuple on attribute x and r is tuple on attribute y, and this is a big O notation which represent the comparison variable, which consists of less than, greater than, equal to sign, not equal to sign, less than or equal to sign, greater than or equal to sign, etc. Okay, so here s and r is a tuple variable, x and y is attributes. Big O notation is here representing the comparison variable, which consists of these or comparison variables, and can be read as s is tuple, s is a tuple on attribute x and r is a tuple on attribute y. Okay, so third form of atom is x is a tuple on attribute x and big O notation c. Okay, here s is on tuple, s is a tuple on attribute x. Here big O notation also represent the comparison variable, and c is constant, which consists of these all. So this is the atom. The tuple relation calculus formula is built up out of atoms, and atom has one of the following three forms. Okay, so now let's move. We can build formula from atoms by using the following rules. Okay, we can build up a formula from atoms, okay, by using the following rules. First rule is atom itself is a formula. Atom is a formula. First rule is what? Atom is a formula. Second rule, we have a second rule. Second rule is if P1 is formula, then not P1 is also a formula. Okay, if P1 is a formula, then not P1 is also a formula. So first rule says atom is a formula. Second rule says if P1 is a formula, then not P1 is also a formula. Third rule say if P1 and P2 is formula. Okay, if P1 and P2 both are formula, then we have P1. This symbol represent or P1 or P2 is also a formula. P1 and P2 is also a formula. This represent and P1 implies P1, which implies P2. P1 implies P2 is also a formula. Our fourth rule is if P1 S is a formula containing a free tuple variable S and R is a relation. If P1 S is a formula, if we have a formula P1 S where S is a free tuple variable, and we also have R is a relation, then there exists. This is we can see here it is a quantified by this symbol, so it is a bound variable. Okay, then there exists this, which represent bound variable S, which belongs to R P1 S, and this symbol is also quantified by this. S is also quantified by this symbol, so here S is also a bound variable. Belongs to R P1 S. It is also a formula. So we can build formula from atoms by using the following rules. We have the following rules 1, 2, 3 and 4. If the following 4 rules are satisfied, then we can build formula from atoms. Okay, so this is for this is what the tuple relation calculus is. So I think you can understand what is tuple relation calculus. If you are going to write these or in your examination, then you can get a full marks also. So thank you for watching this video, and if you liked this video, please like it and also subscribe to our channel. Okay, thank you for watching this video.